Okay, 7.4, B is in Bravo, page 606, bottom of the page. Of course, every time you turn around, they come up with something that makes it more difficult to do these. Okay, so there's our equation. And remember what I said about this middle term? We're going to set that equal to y. Okay, so now let's replace the square root of x with y. But it gives us a pain in the neck because right there we have a square root of x, so that's real easy. We can put a y in there. But this is not a square root of x, so therefore we can't just replace this x with a y because we replaced y with, or the square root of x with y. So is there a way to make this a square root of x? Oh, of course there is. But, again, it's one of those things, how do you even think about that? If I write that as the square root of x and square it, isn't the square root of x squared? Isn't that x? So what I've done is I've just come up with a new way of writing x. X equals the square root of x squared. Okay? So that's one of those things that you just have to have some kind of an epiphany. Like, oh my goodness, I can do that. And it's just trying to remember that. So if you recognize that the square root of x squared is actually x, now I have a square root of x there. So I can put it there. And that squared goes here. Okay? So then it makes it real easy to break this into two binomials. And you get y plus 3, y minus 2. So y equals negative 3 and y equals 2. Okay? Then we look back at our substitution here. And instead of a y here, we're going to put a negative 3 in. So square root of x equals negative 3. And instead of y here, we're going to put in a 2. So square root of x equals 2 for that one. So then we're going to square both sides. And x equals 9. Square both sides. X equals 4. All right. Because we were dealing with squaring both sides of the equation here and here, we have to put this 9 back in the original and this 4 back in the original to see if it works. And you end up finding out that the 9 does not work. It's therefore extraneous. So the only one that works is 4. So let me just real quickly show you what's going on here. Well, let's erase all of this stuff here. Go back to our original problem. Okay, so let's say that we put 9 in here for x. 9 plus the square root of 9 minus 6 equals 0. So 9 plus 3 is 12, minus 6 is 6. So the answer on this side is 6, and that does not equal 0. So that's why the 9 doesn't work. But if we tried 4, I know you're like, I believe you. You don't have to do this for me. Yeah, but I need something to do. So 4 plus square root of 4 minus 6 equals 0. So 4 plus 2 is 6, minus 6 is 0, and that is correct. So that's why the x minus 4 works for us. Okay, and again, because we're just getting kind of an introduction to this, I do want you to know that this substitution method works especially well on some really, really tricky ones, like the last one when we had 4x to the 4th plus 7x squared equals 2. But when we have ones like this, we don't always have to use that substitution method. In fact, let's say that you were doing a math problem and you forgot about the substitution method. So what would you do? You would isolate the x squared. So you would get rid of this. then you'd get rid of this. So you'd add 6 to both sides, and you get square root of x equals negative x plus 6. And now we're going to square both sides to get rid of the radical sign. And that, in fact, this, when we square it, I shouldn't even have written that. I'm going to go ahead and do the FOIL method and square it and get x squared minus 12x plus 36. Let's subtract x from both sides, and I get 0 equals, because that's what we want to do, is we always want to try to set it equal to 0 in order for us to factor. And then I can break this down into, let's see, 9 and 4, give me 36, 9 and 4 are 13. So that gives me x minus 4 and x minus 9. So 0 equals that, so x equals 4, x equals 9. And we tried the 9, and it doesn't work. And 4 is the only one that does work. So you get the same answer either way, and actually, it's easier, isn't it? So on some of these problems, you can use substitution, but you'll find it's easier, like these, not to. In some of them, you'll find it impossible to do this way, and you'll have to use substitution in order to get the right answer. So anyway, that is 7.4. We won't worry about that story problem. Good luck on the assignment, and see what you can come up with.